Welcome to a lesson with Dr. Powell. Let's take a look at another way that we can represent a, a graph or a curve. Let's suppose that we have curve and its coordinates, this is in the xy plane, can be given by an x coordinate and a y coordinate. Well, let's suppose that these coordinates themselves, so this coordinate right here changes with time. Maybe over time it moves here, maybe the point moves along this curve according to a certain rule given by time. Maybe over time it's passing this way. So that means the x part of this ordered pair is a function of time, and so is the y. This whole coordinate pair is a function of time. It changes. So we can represent that by saying x of t, y of t. So x is a function of time, and y is a function of time. In this way, we can represent a curve with a set of two functions, the x coordinate as a function of a parameter t, and the y coordinate as a function of a parameter t. Now we all probably have seen this before. We think about a circle, in fact, the unit circle. On the unit circle, suppose this is the y-axis and this is the x-axis. Let's draw that a little better here. So the x-axis there and here. And suppose that we have an angle right here, and call this angle t. Then what's the coordinates of this point? Cosine of t, sine of t. The unit circle is a parameterization of or has a parameterization, a parametric representation given by cosine and sine. Cosine and sine, as definitions, provide the parameterization of the unit circle. X squared plus y squared is equal to 1. So this is a little introduction to parametric functions or equations. So suppose, for instance, that we had something like this. X of t is equal to 2t, and maybe we have y of t is equal to t squared plus 1. Let's see how we can actually go about thinking about what this looks like. But we also need to know interval for t, for the values of t, for what t could be. Let's suppose we'll let t range from 0 to 1. Now, what's the beginning point? If we plug in t equals 0, we'll see that this graph or curve is going to start at the point 0, 1. We got 0 by plugging in 0 for t here for the x coordinate to get 0, and 0 in for t here for the y coordinate, get 0 plus 1, which is 1. So it looks like we'll be starting at this point right here, 0, 1. Now, where will we end? At t equals 1. Plugging that in, looks like we'll end at 2. We plug in 1 here. 1 plus 1 looks like we'll be ending at 2, 2. So we'll be ending at this point over here. Okay, now let's kind of get a feel for what this might actually look like as an equation in x and y. Now, we can't always do this, but in this case, we can. We can actually solve for t in here in terms of x, because this is x is equal to 2t, which means that t is equal to x over 2. So we can substitute this right in for this t, and notice that y will be x over 2 quantity squared plus 1. Should make sense. This is actually a stretching horizontally of a parabola in this direction, and you've shifted it up 1. And so we actually get this. And notice, but it's only a piece of that parabola. Why is that? That's because we were focusing on the t values in this interval. Thanks for watching.